Saxon's Trig, lesson 114, is about the graphs of factored polynomial functions. And to begin, they start us out talking about a series of terms that you need to know and understand. So a turning point in a graph is basically the hump, or a place where the graph makes a turn of some sort, so an upper point, a lower point perhaps. And then we know that if the overall equation has a positive sign, that the overall graph is going to be climbing. Like it may start here, but it's going to continue to go up overall. And if it's negative, it's going to drop down overall. And then zeros are places where you're going to cross the x-axis here, here, and here perhaps, and then, hump through those curves. That one would be positive because it's overall climbing. And then the local max and local min terminologies are basically your turning points labeled. So this one is up high, and this one is down low. And I might have more than one of these, but I would call that a local max and that one a local min, because they are turning spots in the picture, and this one is at the highest point, this one is at the lowest. And I said you might have more than one. So if you had something like that, you've got peak points here and here, those would be your local maxes. And you've got low points here and here, they would be your local minimums. So you can have more than one set. Then the next part of talking about the graph comes to our turning point theorem. And the book is very clear that this is an advanced kind of a proof, one that you would see more in college than you would in high school, possibly the later half of calculus. But anyway, the turning point theorem for now, what you need to know is if you have an equation and x to the fourth is your highest exponent in that equation, you will have up to, not guaranteeing, but up to, subtracting 1 from it, 3 curves. So this has 1, 2, 3, 4 curves. Its highest exponent would have been an equation with an x to the 5. Now, you would recognize this in your polynomial type equations where you had something like negative x squared plus 4x minus 3, and you recognize that with a single non-exponented y and a squared with the x, that's a parabola, and because it's negative, it's opening down. So what's its highest value? 2, and so if you subtract 1 from that, that means you can have up to 1 curve. Yep, in a parabola, there's up to 1 curve, and there's its local maximum. All right, so then in a third degree, so if you had like x cubed minus 3x squared plus 5 and y equal that, you could have up to 2 turns, a max and a min perhaps, but it could also potentially graph just a single curve. It doesn't guarantee it has to have 2, it might just have 1, but it can definitely not have 3 curves in it because the highest exponent is 3 and we always have to do 1 less than. So then if you had an x to the fourth, like I said, you could have up to 3 curve points, and so that would look something potentially like that, 2 low mins and 1 max point. All right, then we move into dominant term. The dominant term is the one that has the highest exponent value, and it's talking about its coefficient. So since this one is positive, it goes to what I was saying here. Overall, the graph should be climbing. This one was a negative, so overall it should be falling. And then we want to look at flex point. So the flex point is basically a turning point, which I refer back to the hump from the definition from before. And mathematicians also call a flex point an inflection point. So here, where I was saying that our highest exponent value was a 3 and we can have up to 2 turns, the flex point is where I am changing from it being concave down, which this is forming a cave going down, to turning and making it concave up. And so the point at which that kind of changes is right here. So this would be a flex point, and this, the max and min points, would be your turning point. So even though in the definition they're saying a flex point is a turning point, it's not meaning the same thing as creating the hump. It's meaning where I change from being concave up to concave down. And they show you, okay, it's the pictures where, okay, they give you x cubed as the highest one. They're saying that you can have either one curve or two curves. And if you have a one curve and it's positive, so overall the picture should be going up, it's going to be something like this where you're changing gears here. And this would be considered a flex point. That's the start of like a concave down, and that's the start of a concave up. And so that would be a flex point. On the 2, and it's positive, so overall this graph should be climbing. I've got a turn here and a turn here. These are my actual turning points, and then the flex point lands about here where this changes gears from being the concave down to the concave up. And so this is a turning point. And so your homework is going to ask you to do some rough sketches of things. So if it gave you something like x to the 4th, you could have, and it's positive, so one curve would be like a parabola looking thing. You could have the same curve with 3 humps. Oh, I was trying to do 2 humps. I'm harder to draw. No, that's still a 3. Hang on. Can I do a 2? Oh, yes. No. I'm trying to make that a subtle, there we go, a subtle little curve where it's not, so that would be a turn place. Let's see. Oh, yeah. In their pictures, they're showing like this one being longer. This one might be the shorter one with the longer one over here and climbing. It could look more like directly in the middle with a W looking shape. So there's a whole variety of ways that you can draw potential curves for an x to the 4th. The higher the exponent, the higher the amount of pictures that you can have. And if we change that into negative, then just take all of those and flip them over to negative. So like the little one there, bigger one that side, or bigger one then smaller one, or the W, that kind of picture for those. All right, so then to help us in figuring out how to graph, they give us an average of all roots formula. And the symbol for that is x with a line over it. It's not a repetend bar, so don't get confused with that. So it has this letter x with the symbol above, so average of all the roots. So this is taking all of the answers and averaging them together. So the formula that does that is a negative b over NA. Second. I paused there to make sure that I did not skip giving you this piece of information. So even though I'm not explaining the formula quite yet, the average, if you have used this and found that number, so for a quadratic polynomial, if this equals the x value of the vertex, so like if it starts, if it has the x squared as the highest value, then this answer is going to be the vertex, the peak part. If you have an x cubed, this answer will give you the value of the flex point. That's there. And then if it is a quartic polynomial, you've got an exponent of 4, this answer will give you a good idea of the center of the graph. Now they move from that without really using it yet to the zero factor theorem. And you find that in the box on page 630. If P and Q are real numbers, and if when you multiply P times Q, you get a 0, then either the P has to be a 0 or the Q has to be a 0, because the only way to multiply them is to get 0. Or they could both be 0. Now you have already used that without knowing that it was called the zero factor theorem, because you've been using it anytime you've had your equation equal to 0 and then you set this one equal to 0 to solve and this one equal to 0 to solve. That's been the zero factor theorem. At the bottom of the page, it clarifies the zeros of a polynomial function are the values of x that spit out the answer of 0, that makes the f of x 0. And the graph of the function intersects the x-axis at those spots. So it's up here where I talked about the zeros, or where you're crossing the x-axis. Now, let's jump over to example 1 on 631. It asks us to sketch the graph of f of x is x multiplying with 1 minus x and x plus 1. Okay, so the first thing I notice is that I have x times a negative x times an x. So overall, my highest x value is going to be an x cubed, and it's going to be negative. So what things does that tell me? It's opening down. It can have up to 2 curves in the picture. And so they say on the bottom of 631, mentally kind of picture what you might have. I just kind of do it as I graph it. So then to get to the nitty-gritty of where I'm going to graph, so this is kind of my mental start. I first begin my specifics with setting each of these equal to 0, which of course is that zero factor theorem. So x equals 0, that's right here graphing. Then 1 minus what takes me to 0. So if I have to do it the hard way in my head, I'm saying negative x equals negative 1, then x equals 1. Or I can just say 1 minus what? Oh, 1 takes me to 0. Either way you think your way through it, at 1 you get a dot. And here, what makes it equal to 0? Negative 1. So now I have a dot at negative 1. Technically, those should be labeled 1 and negative 1. Okay, so now I have my things. This is where before I always had to do like an XY chart and pick other numbers for X, plug them in and get Y, get a bunch of dots, figure out where they were, and then graph them. But this tells me that overall it's opening downward. So I know I want to start from high here and go down. So from here, I know I'm heading down, and from here, I know I'm heading up in some way. Now I can guess then I might go up and then down and then connect again, or I don't know what I'm doing in here, okay? I can have up to 2 curves, and it's down because it was negative. So since because it's overall going down, I probably won't hump up here. I'm gonna go down here and then jump back up somewhere in between them to get to the 0, then do sort of the same thing. So having the specifics is fine and better, but this just said sketch it, not make it accurate. So a rough sketch of this, that will do. Now example 2, sketch the graph of p of x equals x plus 1 times x minus 2 squared. All right, so x squared and another x is again x cubed, so I can have up to 2 curves, and this is overall positive, so it's going to be going up. And then we're going to do our rough sketch, but we're going to find our zeros, so this would make negative 1, and this will make 2, even though it's squared. I'm going to ignore that part. All right, so those are my 2 starting dots. Up means I'm coming up to this one, and I know I'm going to continue up this direction. What is it doing in between here? Now, I said it can have up to 2 curves. And the other thing that I didn't stop to use is this number in here, negative 2 squared, and that's a 4. It can then mean that I can climb as high as 4, so maybe my picture's doing this, and that would be 2 curves, and therefore an acceptable graph. The other thing that they have not talked about before this example is the fact that I have a squared in here. So this one is more like the y equals mx plus b. It's more of a line part. So a line can cross at the 0. But a squared can only spit out positive answers, so it can't go down into the negatives. It's more your parabola looking shape. So at this dot of 2, I have to be forming a parabola shape of some sort. I can't cross across the axis. I will bounce at the axis and keep it up into the positives. And if this had been overall negative on the outside, then I could do the same thing in reverse and keep it at the negatives. Did I miss anything else? I think that should be sufficient for you for that one.